All right, welcome to your first Algebra 2 with Trig Honors lesson. This lesson is going to be on the real number system, interval notation, and inequality notation. So let's start off by talking about the real number system. So we're going to start by looking at just real numbers, and we're going to look at different subsets. So we're going to define each of the, well, the definition's already there. We're going to say what these are. So the first one is you're counting or natural numbers from 0 to infinity. So the numbers you would say when you count, but also 0. So 0, 1, 2, 3, so on and so forth, infinitely. Those are called whole numbers. So the next one are the opposites of those numbers we just listed. So the opposite of the natural and whole numbers. So all those numbers that are listed above plus their opposites are called integers. All right, so all whole numbers and all integers are rational numbers. Any number that can be written as a fraction is a rational number, so that would be all whole numbers and all integers, plus any other number that can be written as a fraction. And when you look at it as a decimal, it's any decimal that repeats or never ends. So like 0.3 repeating, that is a rational number because it can be written as a third, or a decimal that ends like 0.5 because that can be written as a half. So those are all called rational numbers. Any number that can't be written as a fraction, what they look like as decimals, then that's what they have to be, is they're never ending and they do not repeat, or they do not repeat. So they don't end or they don't repeat. If that's what's going on, they're irrational. So all real numbers are either rational or irrational. They either can or can't be written as fractions. So here we have a Venn diagram, and we want to categorize these numbers here. So to build up this Venn diagram here, all numbers are rational or irrational. So numbers that are irrational can go right here. So those are all irrational, okay? And then we have rational numbers also, right? So rational is going to go here. Okay, and then we have specific types of rational numbers. So we have our whole numbers are the most specific, right? Those are 0, 1, 2. The opposites, those numbers and their opposites are integers. And then all of those are rational numbers. All right, so let's look at these numbers here and put them in the right spot in the Venn diagram. So first off, we have root 5. Root 5 would be a decimal that does not end, so that is irrational. -7 is not a whole number, but it's the opposite of a whole number, so it's an integer, which makes it also irrational. That's why it fits there. Then we have -7/3. That is not a whole number or its opposite, therefore, but it is written as a fraction, so it is a rational. 0 is a part of the whole number system. So is 3. So is 12. 5/4 isn't a whole number or an integer, but it is written as a fraction, so it's a rational number. -2 is not a whole number, but it's the opposite of 1, so that's an integer. Pi/2, pi itself is an irrational number. It's a number that goes on forever and ever, and then if you take that number and divide it by 2, it's still irrational, so pi/2, irrational. And then -2.51 repeating. This symbol right here means repeating. It's a repeating decimal, so that makes it rational. Okay, and then also we're going to define these types of integers. So we have even versus odd numbers. Even numbers are numbers that are evenly divisible by 2, so 2, 4, 6, so on and so forth, okay? And then their opposites also, right? So go in the other direction also. Odd numbers are numbers that are not evenly divisible by 2. So they have remainders, 1, 3, 5, 7, so on and so forth. Also, they're opposites, so go in the opposite direction. Prime numbers are any integer greater than 1, so not negatives, any greater than 1, not including 1. And they have no positive integer divisor other than 1. So they're only divisible by 1 and their self. So we would start with 2. 2 is only divisible by itself in 1. 3 is only divisible by itself in 1. 4 is divisible by 2, so that's out. 5 is divisible by only itself in 1. 6 is divisible by 2 and 3, but if it's just one of those things, it's out. 7 is a prime number. 8 is not. 9 is not. 10 is not. 11 is. 12 is not. 13 is. 14 is not. 15 is not. 16 is not. 17 is. And we could keep going. I'm not going to put ... there because there's no specific pattern to follow for that. But it goes on forever and ever. All right, next we have perfect squares. Perfect squares are the square of any integer. So take a number and square it. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. You should have perfect squares up to at least 15 memorized. 20 would be better, but if you can memorize up to 15 squared, which is 225, that'd be fabulous. All right, next we have interval notation. So we're going to be going from interval notation to inequality notation and vice versa. Interval notation is a way to express the set of numbers giving the starting and ending point, and it can take the place of an inequality, and we will use it more often than inequalities for the next few classes. So what we're going to do is we're going to look at these problems below to see if we can find a pattern on how inequalities can be written using interval notation. So let's compare these two right here. They say the same thing, okay? So in inequality notation, it says x is in between 1 and 9, including 1, not including 9. Both of these say this, okay? This one, let me get my point your finger out here. Nope, that's not what I want. I'll just write on it. This right here says x values less than 9. This says x values that are bigger than or equal to 1. So in other words, bigger than 1, less than 9, that's in between. So this is an in-between statement. This here also says the values in between 1 and 9. The bracket means to include that value. So this is including that value. Parentheses means exclude it. It means it's not included. Okay. Also, in interval notation, it will always be written least to greatest. The smallest number first, the biggest number last. Least to greatest. So if I saw someone writing an invertation and they had 9, 1, parentheses, bracket like this, I know it's wrong. There's nothing that is correct for because it's always written least to greatest. All right, next one right here. This is an and inequality. In interval notation, this symbol right here is the and symbol. The symbol right here is the and symbol. But in math words, it is intersection. So x is greater than or equal to 1. So values greater than 1, right? And bigger than 1. So we start with the 1. We go towards infinity, right? We go infinitely. We're including the 1 because in the inclusivity right there, include that value. And then it goes infinitely. On infinity symbols and negative infinity symbols, you always use a parentheses. All right, and so we use the intersection symbol, and then x values less than 9. So think about x values less than 9. So that's to the left of 9. So we're going to start at negative infinity, and then it goes to 9 and stops. We're not including 9, so parentheses, and we put a parentheses on the negative infinity. These two things say the exact same thing. They both say x values greater than or equal to 3. The first one, that's how you traditionally would see it in inequality notation, and then in interval notation, x values greater than or equal to 3. So greater than 3, so bigger than 3. So we're gonna write down the 3 first, comma, infinity, and you're gonna put a bracket on the 3, parentheses on the infinity. Lastly, this is an or inequality. For an or inequality, we use the union symbol. Union looks like an upside down U, union, and it means or. So it's going to be this or that, right? So x values less than -5. To write x values less than -5, here's your -5, but it's less than. So it's the left, so negative infinity to -5. And we're not including the -5. Union. And then the second part says x values greater than or equal to 2. So write down the 2. Greater than 2 is to the right, so infinitely to the right is infinity. Include the 2 because of the inclusivity there. Okay, so now we're gonna try examples for the rest of these notes here. It says draw a visual representation of each example. So this right here says X values in between 1 and 9. So we're gonna put the 1 and the 9 on our number line, 1, 9. Parentheses on the 1, so we're using an open point to not include the 1. Bracket on the 9, so we're using a 9 to include the 9. And then it's all values in between them, so we're shading in between the two. Next, we have an intersection. So we're looking for the intersection of these two things. Intersection is where they overlap. Okay, so we're going to put what numbers we see. We see 1 and we see 9 again. All right, so the first one says, don't include 1, but I want values greater than 1. Remember, we're looking for an overlap, so I'm not going to shade yet. I'm just going to start thinking of which way it's going. So to the right. Then we have 9, negative infinity to 9. So we have an open point on 9. And then negative infinity to 9 are values less than 9. So that's this direction. So I want to know where those two things overlap, and it's in between those two. So it actually looks very similar to the first one. Now I'm going to come through and erase this thinking right here. All right, next we have 3 to infinity. So X values greater than or equal to 3. So we have 3 on the number line. We use an open point, and then we want values greater than that. Next, we have an OR inequality, yes, it's an OR, but it's not written in inequality. It's a union interval. So we're gonna have those two numbers in our number line, -5 and 2. We're not including -5, and we want values less than -5. So that's this direction. And then we're including 2, and we want values greater than that. So that's this. This is what an OR inequality looks like. It's this or that. They shouldn't be overlapping. All right, next section, express each inequality in interval notation and then draw a visual to go along with it. So first we're gonna write it in interval notation. So there's many ways to think about this, okay? When you're first learning it, this might be the easier way. This is X values less than -5. So you can write down the -5 first. It doesn't mean it goes first in your writing, but like to get your thinking. And then you want X values less than that, right? So less than that is to the left. So to the left is negative infinity. So it's negative infinity to -5. We always put a parentheses on the negative infinity. We're not including the -5. On a number line, how does that look? We have the -5. We're not including the -5, and we want values less than that. So if you look, this diagram matches both the inequality and the interval notation. This one right here, X values greater than or equal to 1/2. Once again, if you want to start off by writing down the 1/2, you can, and then you want values greater than 1/2. Greater than 1/2 are bigger, so we're going to go towards infinity. We're including that 1/2, so a bracket, and then a parentheses on the infinity. 1/2, 1/2, oh my goodness. Include the 1/2, and then all values greater than or 1/2. Okay, if you look, the diagram should match both the inequality and the interval, and it does. Here this says X values in between -3 and 4, not including the -3. So we're going to write down both numbers in between -3 and -4. Include the don't include the -3, include the 4. On a number line, -3, 4. Don't include the -3, include the 4, all values in between. Next one here, this is an OR inequality. So when I have an OR inequality, that is a union statement, and you write two different intervals. So this says X values less than or equal to 0. So values less than 0 are to the left, negative infinity, 0. You're including the 0. You're not including the negative, and well, you're gonna put a parenthesis in the negative infinity. My union disappeared somehow. X values greater than 10, so 10 and anything bigger than that, but don't include the 10 and a parentheses on that. So there's your interval notation, and then drawing that, you need your 0 and your 10. Bracket on the 0, all values less than that. Open point on the 10, all values greater than that. All right, next, express each interval notation and inequality notation. So this says all values in between -5 and 6. So we write that. We're going to write down our X first, okay? Or I do, at least, right? So in between -5 and 6 are values less than 6, but bigger than -5. So if you look at how this looks, it's always using two less than symbols since you're writing it as one inequality here, an and inequality. Put it on a number line, -5, 6, don't include, everything in between. This is an or inequality or a union, so it's going to be an or inequality with two different inequalities written. So I'm going to write down my x first, right? And then its values less than, right? Because it's towards negative infinity, less than 1. And then here we have in between 6 and 10. So it's just like this right here. So x, and then it's less than 10, but bigger than 6. So in between 6 and 10. And then on a number line, we're going to do the 1, the 6, and the 10. We're not including any of those, so open points for all of them. The first one says less than 1, so that's this way. The second one says in between 6 and 10. Last one here, this is -3 through infinity, so it's x values that are bigger than or greater than -3. On a number line, we have the -3, not including it, and then all values greater than that. All right, next one, explain the difference between the following. And if you look at them, they look very similar, except for this has a parentheses and this has a bracket. Remember, the parentheses means that 7 is not a solution. And this means 7 is a solution. All right, because it's not included and included. All right, lastly, we have solve each of these inequalities and then express your answer in interval notation. So to solve them, you solve them just like any other equation, or you solve them like an equation. But if you divide or multiply by a negative, you have to remember to flip the inequality symbol. So on the first one here, I'm going to subtract 7 from both sides and then divide by 3. 3x is less than 27, divide by 3. X is less than 9, and then write that in interval notation. So if you want to write down the 9 first, you can. And then you want values less than that. So less than that's to the left, that's negative infinity. And then you're not including the 9 in your solution. All right, next one right here. We need to get x by itself, so we're going to subtract 4 from both sides of that inequality. So we have -12, or sorry, all three, I guess, parts of the inequality. And then we have a less than or equal to sign, x divided by 2, less than sign 6. Remember, this is an in-between inequality. We need to get rid of that divided by 2. To undo divide by 2, we multiply by 2. So we have -24 less than or equal to x less than or equal to, less than 12. Remember, this is an in-between statement. It's actually saying x is in between -4 and 12. So I'm not drawing that. I'm going to write that in interval notation. So to do that, we write our two numbers in between those two numbers, and we're including the -24, but not the 12. And lastly, x by itself, we're going to subtract 4 from both sides. We have 4x is greater than or equal to 14, and then we are going to divide both sides by 4. We have x is greater than or equal to 4. 14 is not divisible by 4 an even amount of times. So what we're going to do is we're going to simplify that fraction. 2 goes into both of those, the numerator and the denominator. 2 goes into 14 7 times, 4 twice. So writing in an interval notation, I'm going to write down my 7/2. Is x value is greater than that, so that's to the right towards infinity. Include your 7/2, don't include the infinity. All right, that's it for today's lesson. Hopefully you learned from it.